Hey everyone, and welcome back. Remember Moore's Law? You know, that whole thing about computers getting twice as powerful every couple of years.
Yeah, I think most of our listeners will have heard of that one.
Right. Well, buckle up, because we're diving into something even crazier today.
Yeah.
Nvidia's CEO, Jensen Huang, is calling it Hyper Moore's Law.
Hyper Moore's Law. Okay, you've got my attention.
I figured you'd like that. Basically, the idea is that the pace of advancement in computing is accelerating even faster than Moore's Law predicted. And that has some pretty mind-blowing implications. But before we get ahead of ourselves, maybe a quick recap for anyone who needs a refresher.
Sounds good.
So Moore's Law, named after Gordon Moore, one of the founders of Intel, basically observed that the number of transistors you could fit on a microchip was doubling roughly every 2 years.
And since transistors are the building blocks of computing power?
Exactly. More transistors mean faster, more powerful computers. And this held true for, like, what, 5 decades?
Yeah, pretty much. And it fueled the incredible technological progress we've seen. I mean, think about it. The smartphones we carry around today are more powerful than the supercomputers of just a few decades ago.
It's crazy when you put it like that. But there's a catch, right? We can't just keep shrinking transistors forever.
Nope. We started hitting some fundamental physical limits. It wasn't just about how small you could make them. It was about the heat. Packing transistors so tightly together creates a ton of heat.
This is like trying to cram all the power of a furnace into a tiny little box.
Pretty much. And that heat limits performance and makes the whole thing incredibly inefficient. It just wasn't sustainable to keep going down that path.
So if shrinking transistors is hitting a wall, how is Nvidia claiming this hyper Moore's law is even possible? What's the secret sauce?
Well, they realized they had to shift gears. Instead of focusing solely on miniaturization, they came up with this idea of co-design.
Okay, co-design. Break that down for me. What are we designing, and with whom are we coing?
It's like this. Instead of just making transistors smaller, Nvidia decided to optimize every aspect of the computing system, the hardware, the software, how they all work together.
So like a more holistic approach.
Exactly. And one of the key innovations driving this hyper Moore's law is the development of specialized hardware. Nvidia created GPUs, those graphical processing units that were initially designed for gaming, and then tensor cores specifically designed for AI.
So instead of one general-purpose processor trying to do it all, we now have specialized tools for specialized jobs.
Yep. Just like you wouldn't use a screwdriver to hammer in a nail, you need the right tool for the job. And specialized hardware is much more efficient for tasks like AI and deep learning.
Makes sense. Okay, but what about adaptive precision? I've heard that term thrown around. What is that all about?
Oh, that's really cool, actually. Think about when you're on a video call and your internet connection gets shaky. What happens?
The video quality drops, right? It gets all pixelated to keep the call from, completely freezing up.
Exactly. That's essentially adaptive precision. Your video call software is automatically adjusting the resolution to use only the bandwidth it needs at that moment.
I see. So it's like in those moments, it doesn't need to be super high def, so it doesn't waste resources on it.
That's the idea. And NVIDIA is applying the same concept to computing. Instead of using the same level of precision for every calculation, they adjust it based on the specific needs of the task.
So in the context of AI, this means?
It means you can train those complex AI models much faster without sacrificing accuracy.
Wow, that's pretty impressive. So we've got the specialized hardware, adaptive precision, and then there's this whole other layer, right? NVIDIA's new Blackwell platform.
Right. Blackwell is their latest and greatest. Think of it like a super-powered spaceship for researchers.
Okay, I'm intrigued. Tell me more about this spaceship. What makes it so special?
It's designed to handle those really massive data-intensive tasks. Like, we're talking crunching huge data sets for things like drug discovery, climate modeling, astrophysics, the really big scientific challenges.
So it's kind of like a poster child for what hyper Moore's law can achieve, right? Taking those advancements and applying them to solve these huge, complex problems.
Absolutely.
So Blackwell showcases what's possible now. But what about the future? Are there even more radical technologies on the horizon? Things like photonic computing or quantum dots?
Well, those technologies hold a lot of promise, but they're still pretty early in development.
Right.
I mean, they're like comparing a Model T to a Tesla. Both cars, but vastly different levels of technology.
I like that analogy.
NVIDIA seems to be focusing on squeezing every ounce of performance out of what we have today, delivering real-world benefits with tech that's actually ready to go.
That makes sense. But how does all of this trickle down to the average person? Are we going to see these Hypermore's law advancements in our everyday devices anytime soon?
Oh, definitely. It might start with enterprise-level applications, but it'll filter down. Think about it. Faster smartphones, more powerful laptops, seamless VR experiences, lightning-fast cloud computing.
Okay, yeah, now you're talking my language. That's the kind of stuff that gets me excited. But let's talk about the elephant in the room for a second. Cost. All of this R&D, all this cutting-edge tech,
Hmm.
it's got to be insanely expensive. How sustainable is that?
It's true. The costs have gone up significantly. I mean, R&D costs are like 20 times higher now than they were back in the 60s. But Nvidia is really emphasizing efficiency. By designing hardware and software that work together perfectly, they're aiming to create solutions that are both powerful and sustainable.
So less energy consumption, which is good for the planet, and ideally lower costs in the long run.
Exactly. It's a win-win.
If Nvidia can pull this off, it really could be a game changer for the entire tech industry. More power, less waste, and hopefully more affordable technology for everyone.
Yeah, I think it's a really pivotal moment, and it leads to some pretty big questions. If computing power keeps growing at this rate, what does the world even look like in 10 years? What kind of amazing things will be possible? And of course, what ethical considerations will we need to grapple with?
Those are fantastic questions to consider. The future of tech is looking pretty darn exciting. Thanks for joining me on this deep dive. And for all of you listening out there, keep exploring the world of tech because things are changing faster than ever before.